right, let's go for it. Cool. And what is up, everybody? Super good to be back today. Back-to-back live streams. Had one yesterday, doing another one today, this time with a DoK veteran who I'm lucky enough to have known for quite some time at this point. In terms of when we first got connected, did a podcast a while back. That being said, if this is your first time in the Data on Kubernetes community, welcome. I just want to let you know a couple of important things that are going on. It's no coincidence that our speaker today joined us at DoK Day 2022 EU. For a live stream that he did about the topic that we're going to be speaking about today, but taking it much further, right? We got a little bit of a sample about a month ago, and now we're going to be taking a deeper dive. But with KubeCon in mind, just want to let you know that our CFP is open for DoK Day in Detroit, which will be on October 24th. There will be an in-person component. There will also be an online component. So in whatever way you're going to be there, if you would like to submit a talk, the CFP is open. And if you're not sure about what kind of things we're looking for, you have some guidance there on Sessionize, but also feel free to jump in Slack if you have a specific idea that you'd like to share. We want to focus on end user content, getting underrepresented folks from underrepresented groups, speaking spots. So if you aren't from an underrepresented group, but you know somebody who is, you can give the talk together, you can give them their spot, all those different things, so keep that in mind. Another thing in terms of DoK action that's going on next week is that I will be live in London. We'll be doing our third in-person meetup in London. I'll leave the link for that here. If you're in London, if you know someone in London, if you're not sure if you can maybe go to London, this could be a good time to go. We've already got about 100 people signed up. It's going to be really good. We've got a panel and 2 lightning talks. Without further ado, I would like to introduce our speaker who next week will be speaking at KCD Berlin. And I'm going to leave a link to that in case you're going to be around Berlin. I'm going to be speaking about a really cool topic that I'll let him introduce better. His name is Jakub Scholz. He's a Strimzi maintainer and an awesome human being. And we're going to talk today about social media analytics using Kafka. Anyway, welcome. Great to have you back. How are you doing?
Hi, thanks for having me here, and welcome everyone to this meetup.
Awesome. So that being said, for people who don't know you, can you just give them a little bit of background about yourself and maybe how you got into Strimzi, how you got into streaming? What's the backstory?
Yeah, sure. So, my name is Jakub Scholz. For those who don't know me, I work for Red Hat, and really the main focus of my work is the project called Strimzi, and that's all about running Apache Kafka on Kubernetes. And really, the story how I got to that is that even in the past, I spent a lot of time working with messaging. Not necessarily only with Kafka, but also with other messaging protocols. And over the time, that pretty much brought me to Red Hat and to the Kafka space, where we thought, hey, it would be nice if it was super easy to run Apache Kafka on Kubernetes. And that's how we basically started the Strimzi project.
Very, very good. Well, that's a nice thing to hear about how they got started. And also, in addition, with our community, you know, we've talked a lot about database and storage. Really nice to see these other use cases of different kinds of technologies being brought into the Kubernetes ecosystem. And so anyway, without further ado, though, if you want to start sharing your screen, as a reminder, folks, as usual, feel free to ask questions here in the chat. Also, if you have other questions, Jakub is very available on our Slack, in the CNCF Slack, Strimzi Slack, pretty easy to find. And very happy to answer questions. So if you have anything in mind, please let us know, either here or elsewhere. So that being said, take it away.
Yeah, thanks. So welcome everyone to this talk about building your own social media analytics. We already went through the introduction, so I think we can skip this. And let's get to what we will be talking about today. And obviously, if you are interested into analyzing some social media, some social networks, then hopefully you will see some interesting and cool demos how you can do it with Apache Kafka. But even if that's not necessarily your main focus, I think there are some things which you can take away from this talk. And one of them is that Apache Kafka is more than just the messaging broker. And I would like to stress out 2 different things what Apache Kafka is. And the first one is that it's an amazing ecosystem of different components and projects and things which nicely fit together And later during the demos, we will use all different parts of the ecosystem, and hopefully I will manage to show in the demos how nicely and easily they can all work together and cooperate, and how they make it easy to do some interesting or cool things without really too much effort. The Apache Kafka ecosystem starts with the Apache Kafka project, which is part of the Apache Foundation. And that alone has multiple different parts or components. Obviously, it has the messaging brokers, which hopefully everyone heard about. It's kind of the core, the center, which is used for storing the messages and delivering the messages. But it has some other parts as well. There's, for example, the Connect API, which is used for integration between Kafka and other systems. There's the Strimzi API, which is Kafka's own stream processing engine. There are obviously the Java clients, the consumers, and the producers for sending or consuming messages. Then there are the Mirror Maker tool, which is used for mirroring data between different Kafka clusters that now actually has even two versions, 1 and 2. The 2 is the one you should be hopefully using today, as the 1 will be removed soon. But so all of this is already part of the Apache Kafka project. But then it goes way beyond that, because there's a lot of stuff which is outside the Kafka project, which works with these things. And when you use Apache Kafka, it's very common that you use some schema registries to store the schemas of your messages, the structure, and describe them. Obviously, not everyone is using Java, so there are many other clients for other languages, Golang, C, C++, Python, JavaScript, whatever you can think of. There are operators such as the Strimzi project I work on, which make it easy to run Kafka on Kubernetes. There are all kind of UIs. There are different machine learning or artificial intelligence tools which have nice integration with Kafka. If you don't want to use the Streams API, there's a bunch of other stream processing engines which have great Kafka support. And then just for the Kafka Connect API, there's all kind of different connectors for integrating it with other systems. So the ecosystem is really a strong side of the Apache Kafka project. And I think that really distinguishes it from many other projects. And that's what actually allows you, when you want to do something like building your own social media analytics, that actually makes it quite easy, because you don't need to develop everything from scratch. You just take these pieces like a puzzle pieces and basically plug them together. And that way doing stuff is much easier than if you need to build everything from zero. Now, the other thing which Apache Kafka is
right,
that it's
Jakub,
even...
we got a question real quick. So how is Kafka different from Redis?
I would say that it depends a lot on your use cases and how you want to use it. I think in a way, both Redis and Kafka, they are kind of a bit in the middle between a database and streaming and messaging platform. I would say that maybe Redis is a bit more on the database side or key value store side. Kafka is maybe a bit more on the streaming side, but there are things which you can do with both of them. And then there are things which where they would be different, and there are use cases where Redis would be better choice and Kafka would be better choice for other use cases. So it's not like they are completely the same. It's a bit, each one will fit slightly different use cases.
Okay, cool, thank you.
So Kafka is also event streaming platform. Now, that sounds like a great buzzword for presentations, right? And if you would Google it, there will be many different definitions. One definition which I like quite a lot is that event streaming platform should be something what has these 5 different features. It can import the events from some other system. it should be able to store them and distribute them to the different components, clients. It should be able to process these events. And then at the end, usually it should be able to export these events to some other system again. And at least if you look at it from this definition, then the Apache Kafka project fits perfectly, because the different parts of the Kafka project, they nicely match the different functionalities. The Connect API, that's what's responsible for the integration between the outside world and Apache Kafka to import or export the messages. Then the broker, that's kind of the central component, which does the storing of the messages and distributing them to the different clients. And with the Kafka broker, even in some patterns and use cases, you can even use it as a long-term storage. For example, when you do event sourcing and things like that. And then the Streams API, that's really the processing engine, which takes care of the processing part. So again, it's more than just the messaging, more than just delivering the messages from point A to point B. It can do all these other things as well. And that's really what we will do today. So what we will do is we will start with Twitter and the Twitter API. Hopefully everyone knows about Twitter, and even if you don't use it yourself, you probably heard about this Elon Musk guy, maybe buying it, maybe not buying it, and so on. So we will use Twitter and we will use their APIs to get the tweets from Twitter using the Kafka Connect. And we will also use there another great Apache project, which is Apache Camel, which provides a bunch of connectors which can talk with the Twitter API. And then with the Kafka Connect, we will load these tweets and send them to the Kafka brokers. And from there, we will have different stream processing engines, which will read the tweets and then do some stuff, process them, and then in some cases, for example, send something back to the Twitter API. And of course, we will do all of this on top of Kubernetes. And to run the Kafka components, we will use the Strimzi project. So let's look a bit more in detail into the different parts of this. And then after we get through it, we will then jump into the demos and into the source code and into the YAMLs and so on to get more on the practical side of things. So first, we will start with the Twitter API, which basically, like any other service, it has some API which allows you to get different information. You can get the timeline, which is kind of the tweets and retweets and so on from the people you are following on Twitter. You can use it for direct messages if you want to send someone some messages or receive the messages from someone which are not publicly visible by anyone else. And then you can do also other things such as search for some keywords or some queries. And this is what we will be using in the demos to get the data. Now, there is a free version of the API available, which has some rate limits, but I actually use the free version in the demo, so you do not need to have any special paid access or anything. And at the end, when I will share the repository with all the source codes and so on, if you would want to try it at home, then you actually can try it yourself. You can just register the account and play with it. Then the next part which we will use will be the Kafka Connect. Now, that's a standalone component of the Apache Kafka project. I quite often run into people who seem to think that Connect and the connectors, that's part of the brokers directly, but that's not the case. It's a separate process, basically, when you run it separate Java virtual machine, and you run it separately and basically connects to the Kafka brokers just as a regular clients, consumers, or producers. And it works with these connector plugins, which are basically the plugins is what provides the functionality for integrating it with other systems. And there are always two types of the plugins. There are either source connectors or sink connectors. And the source connectors, they are used to source the data. So if you want to get the data from some other system into Kafka, that's when you use the source connectors. And then the sink connectors, that's what you use if you want to get the data from your Apache Kafka brokers into some other system. And in our case, the other system will be Twitter and the Twitter API. Now, the thing is that if you just get the Kafka Connect from the Apache Kafka project, it actually provides just the framework, just the foundation. And you need to add the connector plugins, which implement the support for the different systems and integrations. And if you Google it on GitHub, you will find all kind of connectors. But actually, the Apache Camel project, which is one of the biggest Apache projects, I think, it actually offers several hundred different integrations between different systems, and you can use them in a multiple different ways. And one of these ways is that you can use it as Apache Kafka connectors inside Kafka Connect. And that's what I will be using here. There are three particular connectors. There's the Twitter timeline, Twitter search, and Twitter direct messages connectors, which I will basically use, and they will for me talk with Twitter APIs. So again, it's just another piece of the puzzle which I basically take and I just use it to do all the magic for me. Then the Kafka brokers, that will obviously be the thing which will be in the middle of everything, which will be used to get the messages from Connect and store them, send them to the consumers, producers, and then send it back again. But also all of the other components, they basically use the Kafka brokers to store the data. They basically use it as a storage. So it's Kafka brokers what provides the reliability and availability and the scalability, because the Strimzi API, the Kafka Connect, they basically use it as a storage to store the configurations and to store data. So it's not just used for the tweets which we'll be sending through it, but also as a storage for all the other components. And then the Strimzi API is what I will be using for the stream processing. What's interesting is that the Connect API, it's really a separate process which runs some worker nodes, and when you deploy the connectors, they have some tasks which are scheduled on top of these worker nodes. Whereas the Strimzi API, it actually takes completely opposite approach. It's not some complicated framework where you would have some workers and you would do some scheduling. It's really just a Java library which you can include in your application and just use it. And despite it being really just a simple application, it actually offers quite a lot of functionality. It can do all kind of stateless operations, such as, I don't know, transforming messages, data enrichment, but it can do also stateful operations, such as grouping or aggregations. It can do joins between different streams, between different topics. It can do windowing to kind of process the events based on some time windows. And again, it's basically just clever way how to use the Kafka consumers and producers. So it's very nicely scalable because it basically can scale very well with the Kafka brokers used as the data storage. And then because the Strimzi API is just a jar, just a library which you can include anywhere, I'm actually running my applications using this Quarkus framework or Java stack, which is designed for cloud native deployments, and it has some optimizations for fast startup and small memory footprint, and it can do the nice things such as take Java and compile it natively into a single executable. And it has also great integration for the Kafka consumers, producers, and for the Streams API. But just because I use it, it doesn't mean that you would need to use it if you want to build something similar yourself. You can really just take the Streams API and include it in whatever framework you use, or even if you don't use any framework, you can just include it in your plain Java application and use it there. And then in one of the demos, I will actually do a little bit of deep learning, and for that I'm using this deep Java learning library, which builds on top of some other frameworks. And to be honest, this is not really an area I understand too much, but if you want to get started with something like image classification or object detection or sentiment analysis, this actually, and you are using Java, this actually makes it very easy to get started with something and to get something working. So if you are like me, you don't understand it much, but you want to try it, then this might be a good start for you. And then, of course, I will use Strimzi to run all the Kafka things because, yeah, that makes it just easier for me than to deploy everything manually. Now, that was a lot of talking about the different components, and maybe it's now the right time to actually look into the real thing and how it's running and how you can deploy it, and get a bit more command line experience. So I already deployed all these things, and they are actually running. Some of them are running for a very long time because I don't really use this just as a demo for some talks on meetups, which I deploy 30 minutes before. But if you heard about this dog fooding concept that you should be kind of using your own products, then this is my dog fooding of the Strimzi project and of Apache Kafka. So I actually use this, and it actually runs since I think last summer when I first deploy it, and I just keep updating it. So it's really running and crunching the data all time along, and yeah, so that's why it's already deployed, and I will just show how you can deploy it, but I will not really deploy it live. But the key part is the operator, the Strimzi operator, which is what keeps all of these things running without me really taking care of it daily. And once I have the operator deployed, I basically control everything through the YAML files describing the different components. And now I know that in the meetups here, there were a lot of different operators before, so I don't think I need to explain the concept of operators into too much detail. But basically, you just create this Kafka custom resource if you want to get the Kafka cluster deployed, and then you can just configure all the details of the Kafka cluster. You can give it some resources, like this is really just running on my home cluster, so it's not a huge Kafka cluster. You can configure the listeners, including the things such as the authentication and authorization. So you don't really need to do all these things manually. You just use the YAML to tell the operator what to do. You can configure the storage. There's built-in support for Prometheus metrics, so you get that out of the box as well. And similarly, you configure Zookeeper and all the other components. What maybe is a bit special about Strimzi is that we have these topic and user operators, which allow us to manage with the operator pattern, not just the clusters, the Kafka or the Connect cluster, but also the users and topic which exist in the Kafka cluster. And yeah, we will see that I use it to basically make sure all the demo is using authentication, authorization as part of all the different components. And you basically create the resource like this, and that keeps the cluster running. So you can see when I listed the pods, there are the free Kafka brokers. It's still using Zookeeper, as the Zookeeper-less Kafka is not production ready yet. So the Zookeeper cluster is there as well, and so on. And then in the same way with Strimzi, you can also deploy the Kafka Connect cluster. Now, because I use the authentication, I first use the Kafka user resource to actually create the user, which the Connect cluster will use when connecting to the Kafka brokers. And then I give it the name my connect, and then I can also specify all the authorization rights which it should have. So I need to give it the rights to write and read to the different topics. And then the next thing I will need, and it's commented out here because I don't want to show the real values here, but I will need a secret with the Docker credentials because as I explained, the Kafka Connect itself, it doesn't really have the integrations. It doesn't have the connector plugins, and I will need to add them to the deployment. So what I will do is I will basically tell Strimzi to download these plugins and then build a new container image and push it into my container registry. And that's what this secret with the Docker credentials is needed for. And then obviously to talk with the Twitter APIs, I will need the Twitter credentials as well. So yeah, again, I create secret with all the access tokens and consumer keys, and I will then use it in the connectors as well. And then I have the Kafka Connect custom resource where I tell it all the different things, where is the Kafka cluster, where it should connect to, how it should authenticate, and how it should verify the cluster, the broker's identity. And then in this build section, I can basically tell it, okay, I want you to build me a new container image, which should be pushed here into the Quay registry. And it should have these connector plugins. It should have the Camel Twitter search plugin, where I basically just tell it where it can download the package with the binaries of the connector. And then it should do the same for the timeline connector and for the direct messages connector. And when I deploy it, or when I deployed it some time ago, then Strimzi basically takes these, downloads these, and gives me a deployed Kafka Connect cluster, which already contains all these connectors, and I can just use them. And then another thing which I will need is I will need to pass there this external configuration with the Twitter credentials, because that's what will be needed to be used by the connectors when we create them in the next step. And yeah, again, that's already deployed and already running. And when I, for example, check the status of the Kafka Connect deployment, you can see that it tells me here which connector plugins are available, and you can see all the Camel connectors for the Twitter are here, and they are always both the source and the sync connectors, because we will read some of the messages, but we will also then send something back. So that was the first part of the demo. And now what we really did there is we just prepared the foundation, right? We deployed the Kafka cluster, we deployed the Kafka Connect cluster, and they are now there and running. And we should do something interesting with it. And the first thing we will do with it is that we will create this timeline word cloud. So what we'll do is we will use one of the connectors to read all the tweets from the timeline of my personal account, so all the tweets from the accounts I'm following. And then we will use the Kafka Streams API to analyze the tweets, and we will try to find out the topics which I am most interested in and which are kind of most common in my timeline. And then we will expose the results using the REST API and try to kind of visualize them in some interesting way. And I will first again show how it is deployed, and then we will move to the source code to go a bit through the source code, how that looks like, and then at the end, hopefully it all works, and we should see the results. So the first thing we would need to do is we would need to deploy the connector, which will be reading the tweets from the Twitter API for me. And again, I use the Strimzi operator to deploy it. And so I first create the Kafka topic, which I call Twitter timeline, which where I will send the tweets which it consumes from Twitter. And then I will create this Kafka connector where I say, okay, please use the camel Twitter timeline source connector. And then in the configuration, I say, okay, please send the messages you read to the Twitter timeline topic. The timeline type home, that means basically read the tweets from the accounts which I'm following, which I'm subscribed to. So basically read the timeline. And then I need to give it the credentials to how to connect and authenticate to the Twitter API. So I basically pass that as environment variable. So yeah, it's just a placeholder which is visible in the YAML, but in the actual deployment, it gets automatically replaced by the environment variables from the secret, and that way it can connect and authenticate. And then in the section about the converters, I basically configure the connector to marshal the messages as JSONs, which yeah, is kind of universal and it's easy to read, but it's also easy to process in the application consuming it. So yeah, that's why I'm using JSON. And then again, when you deploy it, I can just get the YAML of the resource from the Kubernetes cluster, and yeah, you can see it's exactly as it was in the YAML, and you can see that it's now running. So it should be consuming the tweets from my timeline. And then the second thing I need for this demo is the actual stream processing application, where again, I create first the user, we already saw this, and then the application itself is just a regular Kubernetes deployment where I use the pre-built image and I just configure all the credentials for the MTLS authentication and so on, and I just run it as a regular deployment, and then I use Ingress to make the REST API and the UI accessible. So that's the deployment. And when I switch here, then we can have a look at the code. And again, as I mentioned, there will be a link at the end with the GitHub repo with all the source code, so you can check it in detail. But yeah, if you are familiar with Maven, with Java development, this is just a regular Maven project, which includes the Quarkus framework. And then it also includes this Quarkus Kafka Streams extension to make it easier to use the Kafka Streams API. But as I said, if you don't want to use Quarkus, you don't need to worry about this. You can use the Kafka Streams API from any application, any framework, or anything. And then in the actual source code, so these are the parts which I actually had to write. All the rest were just putting together different components and different projects, is the actual streams processing application. And every Kafka Streams application basically has this topology, which basically describes how should it work, what should it be processing, what should it do with the events. And in my case, I start with a stream. The stream is basically just all the messages which are coming from some Kafka topic. In my case, it's the tweets topic, which is this Twitter timeline topic where we are getting the JSON messages with the tweets. And then I specify these SERDES. The SERDE stands for serialization and deserialization. and it's kind of a object which helps me to automatically serialize or deserialize the messages. So as I said, the connector will send me the tweets as JSON, but JSON itself is not that easy to work with Java directly if I would work with the nodes and the children and so on. But I use this these serdes, and I have here this tweet serde, which basically automatically decodes for me the JSON into Java classes, and I can then basically just take the tweets and use the getters to get the different fields from the tweet and the different information. So this first line basically creates a stream with tweets which I can work with, and then I use all kinds of different transformations for it. So the first thing in this demo, I'm not really interested in any metadata. I'm not interested about who exactly sent the tweet, where was it sent from, which continent, which country, which city. I'm interested only in the text of the tweet. So basically what I do with this first step, I extract the actual text of the tweet, and then the actual thing which I'm doing here is kind of the beginner demo of Kafka Streams API, and it's counting words. So what I do with this text is I split it by white spaces so that I get the individual words. And then because English or basically any language contains a lot of words which do not necessarily have some specific meaning, so I filter every word which is shorter than 3 characters. And then I have this long list of kind of ignored words, which are kind of the common words about, then, this, that, from, which don't really tell me much about the interest. So I just filter them out. And then what I do is, and I also filter out some other things such as URL links and so on. And then what I do is I basically group these words and I counted how many times did they appeared. And that gives me basically a stream with events, but also a table which basically says, okay, the word Kubernetes appeared so many times. The word OpenShift appeared so many times, and so on. And all I need to do is to just query it and use the results. And for that, I have there this very simple REST API where I basically have this all time / top / and some integer for the count endpoint, which always gives me, for example, the 10 or 20 or 50 most common words, which the Streams application found, and just returns it as a JSON. And to get the data, that's in this interactive queries Java application, where I basically have this method which queries the Streams API application, and it basically gets the values, gets the words with the counts, with the numbers, and then it just sorts them and picks up the top n results and sends them back as a JSON. So it's not that complicated. It's really just few Java files, but when I now switch to the browser, then here is the application opened, and yeah, you can pretty much see what it found. And now you don't know my Twitter timeline, but if you would know, it's actually pretty accurate. So there's a lot of stuff about cloud, Red Hat, Learn, Google, and so on data. But there's also, for example, this AVFC or Villa, or there will be somewhere Aston. That's, for example, about the Aston Villa Football Club, which I follow. So yeah, that's kind of another of my interests, which shows up quite a lot in the timeline, and that's why I see it here in the word cloud. And yeah, I think it really kind of nicely represents the content of what I'm following. Also, as an alternative, you can do a slightly different application. which doesn't count the regular words, but instead focus more on hashtags or on mentions. So the advantage here is that you don't get so much different stuff with the common words, which don't have really any actual meaning, and you get more specific results. So again, you can see that it doesn't completely differ. There's open source, cloud native, Kubernetes, cloud, OpenShift, Red Hat, again, AVFC, that's the football club. So you can kind of see it quite nicely here as well. So that's kind of the first demo, which was about analyzing your timeline. And now I think it worked quite nicely, but to be honest, I know what's in my timeline, so I do not really need this word cloud. And you might not be interested in what's in my timeline, so you might not care about the word cloud either. So let's have a look at something slightly different, slightly more practical, and that's pretty much the demo which I did on the Data on Kubernetes day. We can just go a bit more into the detail. But now we will use some sentiment analysis, and what we will do is we will run some search on Kafka Connect to find some words, some tweets with some special keywords. And then we will use the Strimzi API and machine learning to detect the sentiment of these tweets. And if they are positive or negative, we will basically retweet them with some message. And now you can imagine a more practical use for this than in the previous demo, because if you have some project like I, for example, work on Strimzi, or if you have your own company, you can just configure a search to look for tweets about your project or company, and you can use this to automatically analyze them. And if there is some nice positive tweet, you can thank the person and you can retweet it. Or if it's something negative, then maybe you can find out what's the problem and try to fix it. So yeah, just not to not forget, if you want to take part in this, you can tweet something with the hashtag BYOSMA, build your own social media analytics. That's what the search is configured for. And yeah, if you send such tweet, then yeah, it will be caught in the demo and shown in the code. So again, to get quickly through how this is deployed, we already saw how to deploy the connector. This is pretty much the same. I'm just using the search connector this time, and I specify the keyword which I'm looking for. That's the hashtag which I talked about. And then I have also the second connector, which is this time a sync connector, and that's what I will use to basically retweet the tweets which match the search and which are sufficiently positive or negative. And when I send messages to a Kafka topic, then this connector will automatically pick this up and send it to the Twitter API as a retweet. And as an alternative, it's commented out, and I will not use it in the demo, but sometimes, or if you decide to play with this at home, you might not want your main account to, for example, retweet things which everyone can see while playing with it. So you can also use this direct message sync connector to just send it as a direct messages and keep it less visible. And then again, I have to deploy the sentiment analysis application, which is just a regular Kubernetes deployment. But what's more interesting is how does the application look here in the source code. And so what I really do is I configure these topics. One is the source topic, one is the output topic, and then I again build the topology. And this time I also use the deep Java learning library to load a pre-trained model for sentiment analysis. And that's what I will use to kind of analyze the tweets. And what I do, again, I build the stream. I start with the source topic and the CERDES, and then I just filter out the retweets because I don't want to get alert for every single retweet, just want to watch for the original tweets. And then I basically do the prediction. Again, as I said, if you like me have only very little clue about machine learning and artificial intelligence, this is really easy to use because you just take this predictor and you call this predict method on the text from the tweet, and it gives you back some classification, which basically says that it's either positive or negative with some probability. And I prepare basically this new Twitter message, which says, okay, the following tweet was classified as, and this is where we will fill in the positive or negative, and we will fill in the percentage as well. And then we will share the link. And then we will just send it to the alert topic, and the sync connector will take care of retweeting it. So the difference from the previous demo is that there's no REST API, there's no UI. It's kind of common when using the Strimzi API that you start with some Kafka topic, you do something, you end up with some other Kafka topic without any UIs and REST API. So that's an example of that kind of application. And now when I switch to my Twitter account, one of the many Twitter accounts I use for demos, then I can try to tweet something nice. So let's say the weather today was very nice. It was sunny, it was, let's say, warm and sunny, and we had a lot of fun. Now, I know it might sound silly, but that should give us some nice 99% positive result. So now I have to add the hashtag, build your own social media analytics. And now I'm going to tweet it. And when I switch back to the command line, I can get the logs of the pod, which is doing the sentiment analysis. And it's reading through the messages, and hopefully it sees the message from the tweet, which was just sent. Here it is. So it says, it just logs here that it's tweeting the tweet. When I switch to the browser again, to the Jakub bot account, which I'm using for the retweets, then what we can see here is, yeah, that it found this tweet, which I just published, and it says that it's 99.87% positive. So yeah, exactly. That's why I try to be so super positive here, so that we get this nice result. So that was the second demo. And now let's do the third demo, and let's try to do it something slightly different. Now in the previous demos, it was something prepared. I developed the application, I built the container image, I did the deployment in my Kubernetes cluster, and it's running there continuously and doing some analysis. And that's great. But sometimes you want to do just some ad hoc analysis, just to play with it, try things, experiment with the different ideas, and so on. And you can do this as well. So, for example, my colleague Gunnar Morling, who is one of the authors of the Debezium Kafka connector, which just changed data capture. And by the way, if you are interested in how to kind of link database with Kafka and get the event stream from database into the Kafka topic, then Debezium is definitely something you should look into. But what he always says is that when you tweet something, you should attach some media, like some picture, for example, because that gets more attention and that gives you more retweets. So what we are going to do now is we will try and see if we can confirm this this thing which he's saying, or if he just made it up and it's completely not true. And this time I'm actually going to start with the code, and this is just the properties for the application. So let's just change the application ID so that it doesn't link to some previous runs. And then the application is really simple. It's what it does. It reads again the tweets from my timeline, and it basically filters out all retweets because we don't want to count every retweet multiple times. We want to see it just once. And then it does grouping of the tweets based on some custom aggregation. And then instead of sending it to another topic, we just use this peek method to basically log the results into the command line. And now when I check the aggregation I'm using here, what the aggregation basically does is it is called for every tweet, and it checks whether the tweet contains some images or doesn't contain some images. And then for each of those counts the average number of retweets. So it basically counts the average for the tweets with some picture and for the tweets without some picture. And then basically as we will run it, it will be just printing the results into the command line. So let's get into the right directory. And with this Quarkus framework, you can run this Maven Quarkus dev mode, which is kind of the developer mode, where it will just run it from the command line, and it has all these features like live code changes and so on. But we won't do that here. We will really just run the application. It's now running, and you can see that it's doing the counting. And now it looks like it's at the end of the topic. So it analyzed over 1,500, 1,600 tweets. Remember that it's not counting retweets, so it's just the original tweets. And the result is that if the tweet had some picture attached, then it has in average 1.8 retweets. And if it didn't have any picture attached, then it has only 0.6 retweets. So, I mean, 1,500, that's not that many tweets. That's not a big sample, but it sounds like Gunnar is absolutely right. And if you want to get more retweets, you should attach some pictures or videos or something to your tweets as well. And by the way, it's not obviously not the first time I'm running this, and sometimes the results are much bigger. Sometimes I even had over 7 retweets in average. Sometimes it's less. It really depends on what kind of tweets are in the timeline right now. But yeah, in general, it's always more retweets with the picture than without the picture. So that's it for the demos, but you can obviously try it yourself and try to build other ideas. So for example, I don't know, you can try to find out what's the right time when you should publish your tweets, or you can play with things such as finding out where are the people tweeting about you or your project from, or what applications are they using. And you can of course also try this with other social networks. There are many Kafka connectors for other platforms as well, so it's not just Twitter. Now here are the links for most of the projects I used as a kind of shameless plug. In the Strimzi project, we are right now running our Strimzi community survey. So if you are a Strimzi user, if you are interested in Kafka on Kubernetes, or even if you considered Strimzi, but for whatever reason chose some other operator, it would be really great if you can spend a few minutes and fill in the survey and help us make Strimzi better. And that's it here on this.
Where is the sample repo they could get to get the sample code?
Exactly. So in this link, this jsch.cz/DoK meetup 2022, that's what takes you to the GitHub repository, which which has all the source codes, all the YAMLs, and the instructions how to create the secrets and how to run it. So if you want to try this, this is where you should go, and what you should check out, and where you can find all the details.
All right, pretty good, straightforward enough. As always, amazing to have you with us. And folks, you got the link right here. These slides will be shared as well too. And you're easy to find on Slack, as I mentioned in the beginning. Absolute pleasure. I'm so glad we got to take this further after having the shorter version in KubeCon. This was definitely worth the wait to get the full version, seeing the demos going, taking this that much further. Always great to have you with us. You do an amazing job. Being a maintainer is not easy. I don't want to say it's overrated, underrated, but it's hard and it's not for everybody. I really appreciate your kindness and patience in everything that you do. You have a lot of fans out there, and we're really lucky to have you as part of our community as well. So thank you very much.
Yeah, thanks a lot for having me here.
And before we finish, though, I do need you to stop sharing your screen so that I can share mine.
Yes.
Because as is tradition, and you may be well aware of this, but let me just, I got to do my technical part. There we go. Good. So as is tradition in our community, while we are having these wonderful presentations, we have someone in the back who's doing something equally wonderful, which is creating an artistic depiction of all the different things we're talked about. So here we have our amazing artwork that's always being done by our dear friend Angel, showing the different things that were covered in Jakub's talk, as well as the different concepts that were mentioned, different things that we saw, and being able to put these things together in a different way. So thank you very much once again, and always looking forward to the next live stream, because we know there will be a next one, hopefully before KubeCon. So that being said, folks, thank you very much for joining us today, and we'll see you soon. All right, take care.